First, we begin by identifying the correct angle of the extreme information points. The angles of these extremum information points determine the preliminary conditions for the formation of the attractor. In order to understand which data points will represent the 1.0 of the attractor, I will use the Fibonacci spiral. This tool will help me reveal the logic behind the parabolic structure generated by price. I identify the dimension in which the spiral is most effective. Once I determine the precise time and price dimension according to a data point that has already conformed to the logic of the spiral, I freeze the chart, no movement along time or price, and begin adjusting the arcs to reveal the dynamic liquidity lines, which are the repelling, attracting, and resonating waves of the attractor. The red circle marks the estimated central point of the attractor. It should intersect either with the center itself, or with the 0.5 arc, or the 1.0 arc, which represents the attractor's constant rhythm. When placing the attractor and aligning the 1.0 arc with the correct angle of the extremum information points, the attractor must be calibrated both to the angles and to the logical meaning of the values themselves. For example, the core of the attractor is the 0.236. Price cannot enter the center of the vortex. The repelling force there is the strongest. Therefore, according to the attractor's dynamics, price will be drawn toward it, but will never be able to penetrate it. If your attractor configuration shows price entering the core, you can be certain that its placement is incorrect. As you can see, some laws align perfectly. The angles of the 1.0 information points are precise. Price escapes the core and does not enter the 0.236. And the spiral's point of attraction, marked in red, connects perfectly with the 0.5 of the attractor. However, there are other rules that don't align, which means we must search for the correct configuration. This process can take a long time. Achieving perfect precision is often subtle and elusive. For example, here I know I am searching for a fractal attractor, because the angle between the two highs on the left side of the screen indicates that the macro attractor is much, much wider. But my goal here is to locate the fractal structure of the attractor. Therefore, I base my measurement on price that has already completed a cycle, so I can use the pattern to understand the continuation of the current price movement. It's important to note, the fractal attractor configuration will be effective because it reflects the general flow of price. So when we place it based on the angle of information points from a newly forming cycle, price will respond to the rhythm and liquidity lines of the attractor. Now we arrive at the more complex part, understanding how chaotic systems function. The attractor is built from two different rhythmic structures. 1. A linear wave rhythm. A fixed, incremental sequence such as 1, 2, 3, 4, 0.1, 0.2, 0.3, and so on. 2. A relative wave rhythm, defined by the internal Fibonacci ratios 0.236, 0.382, 0.5, 0.618, 0.786, and the external ratios 1.5, 1.618, including Euler's number 1.718, which is extremely important. While not directly tied to Fibonacci ratios, it plays a significant role in decay and growth within chaotic systems. It's incredibly powerful, elegant, and beautiful, and I'll be making a video about it soon. So what do we have here? We have an attractor divided into three components. The Fibonacci ratios from 1.0 down to the core. The linear ratios within the attractor. The fractal Fibonacci ratios between 1.0 and the midpoint of the attractor. This part is a bit more complex, but it forms a configuration that behaves differently from the original attractor. All three together can provide a highly precise calculation of price relative to time, and reveal how a dynamic system distorts its energetic positioning according to time and mass. Liquidity, the force price gravitates toward, is dynamic. It moves according to time and mass, and the attractor helps us understand this dynamism, thereby allowing us to understand price movement itself. At this point, we can see that price touched the 0.5 level for the first time, but it did not oscillate around it. Because no saturation occurred, price did not absorb liquidity at that level, which increases the probability that it will return to it later in order to complete the oscillation. And as we can see, price eventually returned and oscillated around the 0.5 level once again. After the initial precise touch created a liquidity cluster in that zone. The red line is a dynamic liquidity. And it got bent by time and mass. The nature of the attractor is fascinating. It reveals flows, and the points at which those flows begin to fatigue. Its magic lies in its folding points. Our attractor folds, and the secondary flow shifts in response to the wave structure of its ratios. Each ratio has its own function, its own logic, its own character. And if the attractor is accurate even at the fractal level, we will observe obedience, discipline, and hierarchy between the ratios. A level of precision that is simply astonishing. It's important to understand. Straight lines on a chart are merely curved lines viewed so closely that the parabolic form becomes difficult to detect. A line that appears perfectly straight is simply a segment of a much larger curve. An attractor also represents time. As you can see, the vertical centerline, along with the time-based boundaries of the core, indicate a shift in flow, and potentially a price fold or bifurcation. The extremum points of the arcs act as vertical time markers. Each extremum becomes a significant temporal point, a moment where direction may change or momentum may continue.